Download this code from codegive.com, link in the description below. Understanding and resolving bad operand types for binary operator in Java. The bad operand types for binary operator error in Java is a common stumbling block for new and even experienced programmers. It arises when you attempt to use a binary operator, like plus, dash, asterisk, slash, percent, equals, and, caret, with operands of incompatible data types. Java is strongly typed, meaning the compiler enforces strict type checking to ensure that operations are meaningful and safe. This error is a direct result of the compiler catching an operation that it believes is invalid because the types involved are not supported by the operator you're trying to use. Let's break down the error, explore its common causes, and provide solutions with illustrative code examples. What is a binary operator? A binary operator requires two operands, values or variables, to perform an operation. Examples include asterisk arithmetic operators asterisk plus, addition, dash, subtraction, asterisk, multiplication, slash, division, percent, modulo. Asterisk relational operators asterisk equal to, equals, not equal to, greater than, less than, equals, greater than or equal to, equals, less than or equal to. Asterisk logical operators asterisk and, logical and, logical or. Asterisk bitwise operators asterisk and, bitwise or, caret, bitwise x or. The core problem, type mismatch. The bad operand types for binary operator error essentially means that Java doesn't know how to apply the binary operator you're using to the specific data types of the operands you've provided. The Java language specification dictates which operators are valid for specific types. Common causes and solutions with code examples. Let's dissect the typical scenarios that trigger this error and how to fix them. 1. Arithmetic operations with strings. This is perhaps the most frequent culprit. Java treats the plus operator specially when one of the operands is a string. In that case, plus performs string concatenation, not arithmetic addition. This can lead to unexpected behavior and errors if you expect arithmetic when it's string concatenation. Explanation asterisk. Asterisk the original code attempts str1 plus number 1. Because str1 is a string, Java interprets plus as string concatenation, not addition. Since you try to assign to an int, the compiler signals an error because a string cannot implicitly be converted to an int. Asterisk solution asterisk use integer.parseInt, str1, or integer.value of, str1, to convert the string to an int before performing the addition. Integer.parseInt returns a primitive int, while integer.value of returns an integer object. Both can be used in this context, but integer.parseInt is generally preferred for performance when a primitive int is all you need. 2. Mixing Boolean and arithmetic operators. Arithmetic operators, plus, dash, asterisk, slash, percent, are generally not applicable to Boolean values. Relational and logical operators are for Boolean s. Explanation asterisk. Asterisk the original code attempts flag 1 plus number. Plus is an arithmetic operator, and it's invalid to directly add a Boolean to an int. Asterisk solution asterisk the appropriate solution depends on the intended logic. Asterisk if you need to treat true as 1 and false as 0, which is rare and often a sign of questionable design, use the conditional operator, to map true to 1 and false to 0. This is generally discouraged unless you have a very specific reason. Asterisk most likely, You want a comparison or a logical operation * use relational operators, equals, equals, equals equals, equals, or logical operators, and. 3. Incorrect use of relational/logical operators with non-Boolean types. Relational and logical operators are primarily for comparing and combining Boolean expressions, or expressions that can be implicitly converted to Boolean, which is limited in Java. You can't directly use and, etc., on non-Boolean types unless they can be converted implicitly, which is usually not the case. Explanation ****. The original code attempts number 1 str1. The operator expects two operands that can be compared as numbers or characters. It is not defined for int and string. Solution * compare values of the same type. For int comparisons * use relational operators like equals, equals, equals equals, equals. For string comparisons * use string.compare2 to compare lexicographically, alphabetical order, or string.equals to check for equality. Compare2 returns an int, negative if the first string comes before the second, positive if it comes after, and 0 if they are equal. Equals returns a Boolean, true if the strings have the same content, false otherwise. 4. Bitwise operators with floating point numbers or Booleans. Bitwise operators, and, are designed to work on integer types, byte, short, int, long. They manipulate the individual bits of the integer representation. They are not valid for float, double, or Boolean. Explanation ***. The code attempts number 1 and 2.0 and flag 1 false. Bitwise operators cannot be used on double or Boolean. Solution * use bitwise operators only with integer types, byte, short, int, long. For Boolean logic, use and, logical and, logical or. 5. Custom classes and operator overloading, not directly supported in Java. Java does not support operator overloading in the same way as languages like C++. You can't redefine the meaning of operators like plus or asterisk for your own classes. If you want to perform operations that resemble arithmetic on custom objects, you need to define methods. Explanation ***. The original code tries to use C1 plus C2 directly. Since plus is not defined for complex number objects, the compiler throws an error. Solution * define a method, such as add, that performs the desired operation. This is the standard way to handle such cases in Java. 6. Autoboxing/unboxing issues, less common, but possible. Java performs automatic boxing and unboxing between primitive types, like int, and their corresponding wrapper classes, like integer. However, be mindful of potential null pointer exception issues when unboxing a null integer object, as well as situations where the operator's required type is not met. Explanation ***. Number 1 is an integer object and initialized to null. When you try to use number 1 in an arithmetic operation, number 1 plus number 2, Java attempts to unbox number 1, convert it to an int. Since number 1 is null, this causes a null pointer exception at runtime. While this isn't a compile time bad operand types error, it's related to type handling and a common pitfall with autoboxing/unboxing. Solution * always check for null before unboxing wrapper objects, especially if they might be assigned null values. Debugging strategies. When encountering bad operand types for binary operator, use these debugging techniques. 1. Examine the error message carefully. The error message provides the line number and the types involved in the problematic operation. This is your primary clue. 2. Print variable types. Use system.out.println, variable.getClass.getName, to confirm the data types of your variables at runtime. This can reveal unexpected type conversions or mismatches. 3. Step through with a debugger. Use a debugger, available in most IDEs like Eclipse, IntelliJ IDEA, VS Code, to step through your code line by line and inspect the values of variables during execution. 4. Simplify the code. Comment out sections of your code to isolate the exact line causing the error. This helps you focus your attention on the relevant portion. 5. Refer to the Java language specification. The JLS, Java language specification, defines the precise rules for operators and type conversions. While it's a detailed document, it can be helpful for clarifying subtle type-related issues. General best practices to avoid bad operand types errors. Be explicit with type conversions. Don't rely on implicit type conversions if there's a chance of ambiguity or unintended behavior. Use explicit casts or conversion methods, integer.parseInt, double.value of, etc., to ensure you're working with the correct data types. Understand the data types of your variables. Keep track of the data types of your variables and expressions as you write your code. This will help you avoid mixing incompatible types in operations. Use meaningful variable names. Choose variable names that clearly indicate the type of data they hold. Compile frequently. Compile your code frequently as you write it. The compiler can catch many type-related errors early on, saving you time and effort in debugging. Write unit tests. Create unit tests to verify that your code handles different data types correctly. This can help you identify type-related errors early in the development process. By understanding the causes of bad operand types for binary operator and applying these debugging techniques and best practices, you'll be well equipped to prevent and resolve these errors effectively, leading to cleaner, more robust Java code.